Hey everyone, hope you're all doing very well and welcome back to another video here on the channel. In today's video, we're going to be talking about differentials and specifically why would you ever want to have one locked in a radio-controlled vehicle. Now we're going to be able to break this down into a few different key areas within the vehicle because if you operate a rear-wheel drive only radio-controlled car, you're not going to find a differential in the front nor a differential in the center of the vehicle. However, if you have an all-wheel drive, a four-wheel drive radio-controlled vehicle, you're going to find one in the front end, but you may or may not find one in the center. So it's a good idea to recognize how many differentials you have in your radio-controlled vehicle before we start talking about the specifics in this video. Before we jump right into the core of this video, I did want to thank the Patreon members for your continued support, and I want to thank the new members on there. I know that a lot of you guys are downloading the spreadsheet because a few of you are reaching out and asking specific questions about functionality within the spreadsheet. So it's good to see that you guys are using it. Anything that you want to see on that spreadsheet, let me know and I can get that done for you if it is truly possible. So let's jump right into it, talk about some of the advantages that we get, and we're going to first start off by discussing the center differential, because this is the one where I believe you can have the biggest advantages when it comes to locking the differential. Let's go through it. So when it comes to locking the center differential, a few key advantages that you get when you do this is you're able to prevent a lot of the ballooning type phenomenon that happens when you have too much power that goes to the front wheels and they don't have enough traction. If you have very minimal traction, having power at the front end is not going to be all that helpful. Under heavy acceleration in a radio-controlled vehicle, whether it's on road or off-road, you can have a lot of that weight shift towards the rear end, lightening up the load there in the front end. And as this is done, a lot of the traction is lost because the vehicle is lighter in the front end, and what this causes in our radio-controlled vehicles is the tires to unload. All the power that gets sent to the wheels goes directly to the front end because they have the least amount of traction. This is counterintuitive to what we actually want and maybe what you would actually think. But the power is always going to go to the path of least resistance. And if that least resistance is the tires that have the least traction, that's where you can get the actual ballooning that happens with the wheels. This is where the wheels are spinning at a very high rate of speed. And when that does happen, you have a chance of growing out that tire in diameter, which is not healthy for the tire, nor for anyone standing around if that tire were to let go. Now, here's something very interesting about the ballooning that we see in differentials. A differential allows the tire to actually spin faster than if your differential were locked or didn't exist at all. I want to show you a demonstration on how we can actually achieve a higher speed on the front wheels when we break traction with those front wheels and we have a differential of speed between the front and the rear end. What I want to show with this rear differential here in my hand is it doesn't matter whether it's a rear, front, or center, they're all going to act the exact same way. You have one input and two outputs from a differential. So what I'm going to show you is that the speed that we rotate the main gear, so this is the motor that's going to rotate the rear tires, and I'm going to go through half a turn, and then I'm going to go through a full turn. If you're watching, it doesn't quite make it to the 180-degree mark. So if we back that off, we're at about even where this is pretty horizontal. So again, I go half a step, and then I go a full step, and we don't get 180 degrees. Now watch what happens if I bring this back to where we started from, but now I'm going to hold the other side of this differential locked. So this would essentially be me driving the radio control vehicle and applying too much power, and then the front wheels on my radio control vehicle begin to unload, allowing this to spin up. So this is what happens in our half turn, and then if we go through for the full turn. So now you can see we actually get past the 180-degree mark. What this is essentially telling us is that in one revolution of our input, we either get about this much rotation if the wheels are traveling at the same speed, or if you have power being biased towards one side, you actually get more of a rotation. This allows the front wheels on a radio control vehicle to actually travel at a much higher rate of speed than it otherwise would be running at. Now, a second advantage to having a locked center differential is you're going to have a lot more traction in the rear end of the vehicle. And this is going to allow you to accelerate harder, whether you're on road or off road. You can experience the more aggressive acceleration in both of these areas. The third advantage is it allows a very experienced driver who really knows the vehicle well to handle the vehicle in such a way where they can maximize the performance. They can live right on the edge between having all the traction in the world to breaking that traction and losing control of the vehicle. I put this in the advantage category because when you have an open differential or a fluid filled differential that can slip and cause differences in speed between the front end and the rear end of the vehicle, you don't have the control to actually get the traction that you're missing out on. And because of this, you ultimately lose performance capabilities within the vehicle. Let me know in the comment section below if you prefer to have a lock differential or not. Now that we know and understand the advantages of the lock center differential, how do you know if it is best for your application? Well, there's a couple points that we can talk about. And if you're running an off-road rock crawler type vehicle, you probably want to have a lock center differential in a few different instances, especially when you're trying to crawl rocks and you need all the traction that you can possibly get. This is going to be very critical and important to you. The same idea is going to be true if you're running a buggy in an off-road type environment or you're running a more on-road type vehicle on pavement. If you are running into traction limitations where you're not getting enough traction or power sent specifically to the rear wheels, this is where you can see a better or bigger improvement by locking that differential. Now, there is a third element to this, and that is if you are very comfortable and confident with your radio control vehicle because you have a lot of experience that back the skills that you've developed over the years, you are probably going to feel very confident and comfortable by locking your center differential and experiencing what that offers for you. I would also suggest if you are new to the hobby, keep the differential in the center unlocked. It just makes for a much more forgiving run of that radio control vehicle. We're going to talk about the disadvantages here shortly. Let's now cover the front and the rear differential. When it comes to front and rear differentials, as opposed to when we talked about center differential splitting between front and rear, a front or rear differential is going to bias between left and right. So this really impacts our cornering capabilities. If we are looking at the advantage of locking the front end, this is going to help improve the traction on those two front tires. And the same applies for the rear end. If we lock the rear differential, we're going to see power delivery quite evenly between the left and the right rear tires. Now, there's very limited amount of cases where this would be beneficial for you. A good instance might be for a high-speed radio control vehicle, drag racing type vehicle. And another area where you're going to see a radio control vehicle with locked front and rear differentials is for rock crawler type vehicles. This is going to allow you to maintain maximum amount of traction as you navigate those rough bits of rock and rough terrain. So this is where you'd really ultimately want to have a lock differential. Now, when it comes to the front and rear differentials, my personal preference is to not lock those differentials because I do prefer to have the capability of making a very comfortable corner, even in my more high-speed type radio-controlled vehicles. Now, let's talk about the disadvantages as it relates to all three of the differentials that we talked about, the front, the rear, and the center. The biggest disadvantage that I see is that you have to have more control in operating the vehicle when you have all of these differentials that could possibly be locked. If you lock the center differential, it's going to be sensitive if you try to overpower the radio controlled vehicle, breaking traction. This can allow you to get sideways very quickly, and you have to be able to recover quickly from it, otherwise you lose the vehicle and it slides off the road. Now, when it comes to the front and the rear, it's a very similar situation, except everything sort of gets a little bit more amplified, especially when you lock the rear differential. You're going to have the ability for those rear tires to overtake the front tires, and that's where you get the rear end of the vehicle kicking out to the side, and the same thing happens where you can lose control of the vehicle and off the road it goes. Now, when it comes to the front differential, you lose the control as it relates to cornering because those tires want to travel at the same speed, so you get a little bit of understeer, which makes it a little more challenging to control as you go through a corner. And overall, locking the differential prevents and restricts you from actually making corners. So if you have a rock crawler and all your differentials are locked, you're not going to have a tight turning radius. What's really cool about the Traxxas Summit is the one vehicle that I know of that right from the factory, it offers you the control right on the transmitter to lock the front and rear differentials. Now, what's really cool about that is on the fly, you can actually lock the differentials as you're going into some rougher terrain where you need more traction. And as you come out of that terrain and you're back onto a more normal terrain, you can actually unlock those differentials so that you have a nice tight turning radius again. This is something that I find truly cool to play around with, especially since it's coming from me where I don't operate that much in an off-road type environment. Well guys, I hope you enjoyed this video and learned something about lock differentials in a radio controlled vehicle. As always, like the video if you do. Don't forget to hit that sub button so that I can see you guys in the next video. Thanks a lot for watching. See you in the next one.